Guys, welcome back. My name is Avinash, and in this video, I'm trying to explain how exactly Azure Load Balancer works. See here, this is a simple topology of Azure Load Balancer. So generally, this load balancer is designed for horizontal scaling. So you have one VM and you're getting a lot of load to that VM, and so then immediately you're going to add some more resources or you're going to upgrade that configuration, right? So, but that upgraded configuration till certain point it is okay. So one VM is not able to handle the traffic. So definitely we can go and provision multiple VMs and we can scale the load across those VMs. So technically that is a horizontal scaling. So this load balancer supports designed for horizontal scaling purpose. So first thing, here in Azure Load Balancer, we have two components called front end and back end. So in between, we are going to have a load balancer. So this front end is nothing but a public IP address, and this back end is nothing but a group of VMs that can deliver our application. So this load balancer act as an intermediate one. It will take all the load from here, all the data request from here, and it is going to distribute to backend VMs. All right, again, on top of this, we have internal load balancer and internet facing load balancer. So internal load balancer is it works only within the Azure network. Outside of world cannot directly hit that, and we are not going to get any public IP address. If it is a public facing one or internet facing one, we are going to have a public IP address for our load balancer, and we can access even from outside world also. All right, so to explain this, I already have couple of VMs here. This is VM1 and this is VM2. So both are running with the Linux operating system. I have used the user data to make these VMs as a web server. One more point to add here. I have not added any public IP address to these VMs. So you can observe there is no public IP address while launching the VM itself, while launching Azure VM itself under networking part. So here we have an option to choose public IP address, right? I have set it to none. Okay, so now I have a machine to test the output. You see here, these are the two IP addresses. 10.0.0.4 is one web server IP address, 10.0.0.5 is another web server IP address. All right, so you can even verify that IP address. Click here and navigate to network, and you see this is 0.4 and this VM is 0.5 here. Now, I want to create a load balancer and I want to add both of these VMs as a backend resources, and I want to deliver whatever the website these VMs are giving, I want to deliver that via load balancer. So for that, first let me go and search for load balancers, then click on create. So whenever you are creating a load balancer, so, first, as you know, it will ask for the subscription. In what resource group you want to create, you can select that. And what is the load balancer name you want to give? I'm going to call this as Dev Azure Load Balancer. So, in what region you want to create, you can go and select, okay, my resources are in Central India, I'm selecting Central India. So, then we need to choose an option called SKU. So we have three options actually, standard, gateway, and basic. So you can choose either standard or basic. So the real difference between the standard and basic SKU is here. I'm using official Azure documentation. So here the standard and basic. So basic is designed for dev or test environments. It's not recommended to deliver your production workloads with the basic load balancer. So we have some limitations. So it works with only NIC based, not IP based, and it supports only 300 backend instances. But if you are taking standard load balancer, So it is capable to scale for high. It gives high performance and ultra low latency, and it supports 600 configurations, front-end IP configurations, and it supports 5,000 instances. And also one more point to mention here, the SLA. As this standard is meant for dev or test environment, Azure won't give any SLA. So, but for uh, standard, for basic, no SLA. When coming to standard load balancer, so we are going to get 99.99 percentage SLA for this standard load balancer. So basically, SKU means stop keeping units, right? So I'm going with the standard. That is what Azure also recommend. So then type public or internal. As we discussed, public is like a internet facing one. We are going to get a public IP address for this load balancer. So in which scenario we are going to use internal? For example, you have some database servers or the server or application you want to uh, like deploy and you want to deliver only to Azure resources, or else you have hybrid environments and with the help of VPN and all. So in that scenario, you can go and choose this internal. For now, I'm going with public. Tier, we have regional and global. Regional, like the resource or backend network interfaces actually will be within region. If you're selecting global, a cross region load balancer is going to create like, okay, let's go and select regional for now. Click on front end IP configuration. So as I told you, if you observe this diagram, we have front end. So we are going to configure this now. As it is an internet facing or a public facing load balancer, so click on add front end IP configuration. So then we need to choose an IP address. So I'm going to call this as front end IP, and what public IP address you want to add. So basically, I have a couple of IP addresses here, one with jump server and another one. So let's go ahead and create new. Click on create new, and you can give this. Okay, so public IP, and I'm going with zone redundant, Microsoft network for routing preferences. Click on OK. So now one public IP address is going to create, and that act as a front end. So whatever the public IP address we are going to get here as a front end IP, so that public IP address only allocated to our both the VMs. You observe this VM1 and VM2 both don't have any public IP addresses here. Let's see what happened once we create this load balancer. Now click on next. So we need to configure the backend. So backend is nothing but like what VMs you want to add and how you want to route the traffic from load balancers to these backend resources. So that we are going to select. I'm going to click on add backend pool. Backend pool name. Backend pool is a simple name I'm giving. So in what virtual network you're creating? I'm creating it in compute RGVnet. So you want to register your resources by using IP address or by using NIC, network interface cards. You can click on add here. So then I'm going to choose this VM1 and VM2. Both I want to add to my load balancer. Then click on add. All right, so both are added now, then click on save. So you can verify here. There is a pool called created here with the name called backend pool. So to that pool, VM1 and VM2 both added here. Right, then click on inbound rules. So when coming to this rules, so this um, you know whatever the traffic coming from front end to this load balancer to where it need to route. So load balancer basically is going to listen on port number 80, the default one or common scenario. It listens on port number 80 and it sends to backend to VMs on port number 80. If you want to listen on 8080 here and you want to send to a different port or group of resources, then you can configure so that by using load balancing rules. I'm going with a very simple rule for now. Click on add a load balancing rule. So then give a rule name. So basic LB rule is the name I'm giving. I'm going with IPv4. So what is a front-end IP address and what is a backend pool? Now, whatever the traffic coming to this front end, okay, I'm going to redirecting it to backend, but what port? So whatever the traffic coming to front end on port number 80 on the TCP protocol, so the same traffic I'm going to send it to backend port number 80 for our resources, backend resources. Okay, this is a front end port and backend port. Load balancer is going to listen on 80, and this health probe, basically it's a health check. Whatever the resources we are adding, resource is nothing but Azure VMs. So whether these resources are healthy or not, if these resources are healthy, then only the load balancer will route the traffic or send the traffic. So how load balancer will come to know about that? So by performing the health probe, by performing health check, click on create new. So give a health probe name, dev VMs health check. What protocol? I'm going to use HTTP protocol. I'm going to verify over port number 80. If you want to verify with slash, you can give. If you have any specific web page to perform this probe, like status.html or like index.html, you can even give that. How frequently you want to perform this health check, you can even pass at intervals also. Then click on OK. All right, we are creating one health probe now. So then I'm going with all the default options, click on add. So technically, this IP address is a front end. These are the backend resources. These are the backend resources. And this is a routing option between this front end to backend. Then click on outbound, not configuring any now. If you want, you can give it tags, review, and create. So it's running a final validation. Okay, seems all settings are valid. Then click on create. All right, this is going to take some time. So if you are looking for redundancy for our load balancers queues, so when coming to this basic, so the redundancy is not available actually. But when coming to standard, we can configure zone redundance and zonal redundance whenever we are using this standard load balancer. And also, the standard load balancer is closed. We need to take care about inbound as well as outbound rules. But basic load balancer, so only inbound is allowed. And the security for basic is open by default, and NSG, Network Security Group, is purely optional. But when coming to standard, the traffic security is closed security. So we need to take care about network security groups also, NSGs also. All right, so this is still creating. All right, this got created. Then click on go to resources. Now, here, go to front end IP configuration. We got a public IP address here, and here is the backend pools. So whether both the resources appeared here or not. So if you want, you can select this backend pool, and you can, like, later on also you can add, you can remove some resources from this backend pool. So go to health probes, whatever the one we configured, so that you can find it here, and whatever the load balancer you created or you want to modify, you can do that from here. All right, so let's go to virtual machines and let's give a refresh. Earlier, we don't have any public IP address here. Give a refresh, and if you scroll to right, and here you see this is the public IP address is now added to our VMs. So basically, this public IP address is our load balancer public IP address. So go to your load balancer, and click on front-end IP configuration. You see this? This is what the public IP address. Now, to access this load balancer, grab this public IP address, give that here, and you see the traffic is going, and basically the traffic will go to both the resources. So if you stop, or if you stop one of the VM, or if you're taking another session, something like that, so then the traffic is going to redirect to multiple resources, right? So basically it won't work with the round robin mechanism. Okay, so it works with 5 tuple hash mechanism. So that's the reason. But you see now, when I waited for a second, when I gave refresh, it is going to web server 2. Again, if I wait some more time, if I gave refresh, my request may go to web server 1. All right, so both resources is now added to load balancer as a backend pool, and the same IP address is delivering or distributing load across these multiple VMs. All right, so that is what exactly, how exactly this Azure load balancer works. Thanks for watching this video, guys. Please subscribe.